Hey robot makers, welcome back to part 2 of Learning MicroPython. Let's go over to our keynote and continue our journey. So in this part we're going to be looking more at how we can control the flow of our programs and use things like loops, and also look at variables and data types as well. So let's have a deeper dive into this. So values and variables. We can store lots of different things in MicroPython. We can store different types of numbers and text, and even our own creations, our own classes of things. We'll have a look at those in a slightly later episode though. So if we want to store things in lists and dictionaries, we can do that too. The difference between a list and a dictionary in Python is a list is simply a collection of items. It's like an array of things. So a dictionary is like a list, but it can hold two things. It can hold keys and values. So say we wanted to have the name and age of a person, we can store those two things together in a dictionary, and we can then use one of the keys to look up the value associated with that. So we wanted to store, for example, people's names and ages. We could say Kevin 47, Alex 20, for example, and then if we want to just find out what the age of Kevin is, we can just pass in that key and it will give us that value back. So that's the main difference between lists and dictionaries. And programs often need to work with numbers and text, adding and subtracting, asking questions and processing answers. So Python is going to really help us do that kind of stuff very easily. Python is also able to label those different types of variables and values to make different kinds of commands available to us. And we'll have a look at what those are shortly. So let's have a look at different types of data in MicroPython. So we have an int, which is a whole number, and that can be positive or negative. So examples of that as just the normal 1, 2, 3, 4, and there can also be different values like that. We also have float, which is a decimal number, so any number that has a decimal point in it. That could also be negative or positive. So we've got an example there, 3.14 pi as you know it. You can have minus 2.5, you can have 1.6666, as long as you like. Next we have string. So string of text. I always imagine it's like a garland, a string that's hung up, and there's lots of characters all in a row on there. So a line of text is a string, so things like hello world, my name is Kevin, there's the examples there. And you can also notice that the double quote marks, or we can use the single quote marks. We can use them, and the reason that you would probably want to use the double quotes over the single quotes is the double quotes anticipate using apostrophes in your text. So if you've got like, this is Kevin's lair, if you have an apostrophe, MicroPython might think that that's the end of the string, so you need to wrap it in some double quotes instead of a single quote to overcome that. Next we have the lists. So a list is a collection of words or numbers or objects or any kind of item that we can store in Python, and we can add and remove that to the list. So these lists are not fixed. We can append them, we can pop things off the list, we can do all kinds of things with them. So examples there, we've got cat, dog, fish, gecko. Notice they're in these square brackets. We can also store numbers, so we've got a sequence of numbers there as well. And then next we have the dictionary. So dictionary, they have these sort of curly braces, and you can store these key value pairs. So we've got name, Kevin, address, UK, age 45. Maybe I wrote this a while ago when I actually wrote this original Python tutorial, and I've recently upgraded it to MicroPython. And then we've got object. So in Python, everything is an object. Object is kind of like what everything inherits from. So when you create something like a number, you're actually dealing not just with a numeric value, like a literal value of 3. You're actually dealing with an object that has all different kinds of helper functions associated with it, and the value of that is 3. You'll see object used quite a lot in Python and MicroPython, and what we've got there as an example is the object of a cat class. So we can create a class of an object that has various different properties and actions that it can perform. Next is, it's a bit of an unusual one, this one, a tuple or a tuple. So this is a collection of multiple items, very similar to a list, but it cannot be changed once it's been created. And the reason for this is it actually uses less memory. It's more efficient use of memory than a list. So on our MicroPython device, this might be something that's useful to us. We might think, well, what kind of thing would we store in a tuple that we wouldn't store in a list or a dictionary? Well, it might be something like, say we have a robot and we know it's only got 4 motors on it. We want to address the motors and the pins, we want to associate them. We could store them in a tuple so that we've got those two things paired together, and we know that that's never going to change. So it's a way of looking things up in an organized way, and it doesn't change. So one thing worth noting is that when it comes to duplicates in things like lists and dictionaries, they all have different behaviors. So in a list, you can have duplicates. Just looking down at my notes there, you can have duplicate things. So you could have fish, for example. That'd be perfectly fine in a list. In a tuple, you can also have duplicates in there as well. But when it comes to a dictionary, you can only have one instance of each entry in there. And that's because just like a regular dictionary, you only want to have one entry per thing that's in there. And in fact, if you're trying to assign something and you assign another one of the same value, it'll just overwrite the original one in the dictionary. We've looked at tuples there, and the very last thing on our list there is bytes. So a byte is a group of 8 binary digits or bits ones and zeros on or off, and they're used to store data. And we're going to have a look at that in a much more granular detail in a minute. So a couple of examples there of bytes is we can address these in different ways. You can just store a value such as 255, and that's the maximum value you can store in a byte. You could address that in binary, so you could do 0b for the binary and then 8 ones or zeros, or any combination of ones or zeros in there. There's 255 different combinations there, 256 including zeros. And then we've got 0xFF, so this is the hexadecimal format. FF is the highest value that you can store in a byte. And you'll see that often in things like hexadecimal values for colours, for example. If you're doing things like CSS, you might often store the colour value as 3 pairs of bytes to represent the red, green and blue. So let's have a demo, shall we? Let's have a look at strings, numbers, sequences of collections of things, lists and dictionaries and tuples, and objects and bytes. Okay, let's get over to Thonny and start this off now. Okay, so I'm over here in Thonny. I've got my Raspberry Pi Pico plugged in. I can just show you that's just on the table here, and we're just using Thonny. Okay, so we looked at how to install Thonny and set that up in the first episode. So if you've not watched that already, go back and watch that now. Okay, so let's have a look at strings first of all. So I'm just going to come over here and we're going to define a string. So I'm going to define a string as being my name. So I'll say name equals, and then I'll just use Kevin. So these little double quotes are going to tell MicroPython that what I'm putting into the name variable, that what I'm assigning into it is a string, and that the string is called Kevin. So let's just do something like print name, and then let's just run this. So there it says Kevin. If we want to find out what type of variable we're using there, we can actually use the type. If I wrap this inside the print statement and I run this, type will tell us what kind of object we're using. We're using a string class. You can see there we have string. So let's continue looking at strings. Let's make this, let's just get rid of that type bit and let's just make it print name out. Let's add some extra things in here. So what I was saying before about double quotes anticipate apostrophe use in English. So if I say Kevin's Robot Lab, like so, there we go, Robot Lab, and I press run, it prints out there Kev's Robot Lab. Now if I didn't use that, if I used a single quote and I had at the end of the line here another single quote, look what's happening. It doesn't understand what's going on because it thinks that the string is Kevin and that that's the end of the string, and that this S Robot Lab apostrophe, it doesn't understand that. If I try running this, it's going to say that's invalid syntax. That doesn't make sense syntactically. So what we can do there, we can either put a / before that, which looks ugly, doesn't really make sense, but syntactically what that's saying is what follows is a special control character, which is the apostrophe. But that doesn't look very nice. It's much more elegant, instead of doing that, just to use the double quotes all the way through like so, and therefore that's now syntactically correct and it looks pretty as well. If we weren't doing that, we could just use the single quote. If it was just print out the word Kevin like so, we could just use pair of single quotes and that would work fine. So the preferred way of doing this is double quotes. Okay, that's how we print out a string. Let's look at some numbers next. So let's leave that there as the name. Let's go for age, and I'm going to store in there 47, and let's print out age and run that. So we can see it's printing out 47, but let's again have a look at the type of this. So I'm going to put the word type in brackets, and I'm going to see what kind of type age is. Age is an int. It's an integer. It's a whole number, plus or minus. We can have negative numbers in there as well. Now if instead of doing 47, if I did 47.5 and I run that, it's now a float. It's now a floating point number, which means a decimal, and you could have as many different decimal numbers, not letters, after that, and it would be fine with that as well. It recognizes it because of the full stop. Decide what kind of number you're going to use and stick with that. It's not really good to sort of switch between them partway through your program. You're likely to generate errors there when it comes to numbers. So that's strings and numbers, floats and integers. Let's have a look at doing a list next. Let's have pets. So I'm going to create a list of pets that I have. So in here, I'm going to do quotes, and the first one is going to be Archie. So you may well have seen Archie on a few of our shows. We also have Minnie, and we also have, let's have Trixie in there as well. Trixie's our cat. We have a few cats. Let's have, which other cats have we got? We've got Tigger, we have Bella, and also we have the other cat, which is Cookie. Okay, so if I now print out pets like so, we can now see almost exactly what we've got up here, but it's changed the speech marks to single quotes there just because it's decided to do that. That's fine. Interestingly, if we wrote in there instead of Minnie, we did Minnie's fur coat, and we run that, I wonder what it will do there it's actually changed it to double quotes there. So it's kind of defaulting to single quotes if it can, probably because it just looks prettier on the printout. So let's go back there to mini, and that's what we can do with pets. Let's have a look what type that is again. So let's do type, and let's run that and see what it says. So it says it's a list, and we can do things with lists, and we'll have a look at those in loops. Loops are very useful for doing things with lists because you can loop through each item in this list one at a time and do various things with it, and we'll have a look at that one in a minute. Now for a dictionary, say I wanted to store the age of these pets as well. So let's do pets ages, and this time I'm going to use the curly braces because it's going to be dictionary, and I'm going to have the first one, which is Archie, and then we use the colon to say, so Archie is the key, and the value for Archie, let's have his age in there. I think he is 5. I'm going to have a comma. We always separate elements in our lists and our dictionaries with commas as well. You can put spaces after these as well, that's fine, it doesn't mind about that, it will literally ignore them. So there's it, Archie. Let's have mini next. So you can see that I can actually use these things interchangeably, the single quotes and the double quotes. It is best to be consistent really, but I'm just showing you that you can do that. So I think mini's a year younger, and then let's have Tigger, let's say 0.9, so I'm going to have a floating point. So you can, in dictionaries, have different pairs of things. You don't all have to be exactly the same format. It's probably a bad programming technique to mix different types in there, but you can do this. This is completely valid. So let's go and see print out pets ages now. Let's run that, and we can see there Archie 5, mini 4, Tigger 0.9. And if we do that type thing again, let's have a look what it thinks this is. We can see that this is a dict, this is a dictionary. And finally, let's do the same again. What's not going to change? The names are not going to change. So I'm going to copy that dictionary there. But what I'm going to do, I'm going to, let's call it pets names. And instead of having the square brackets, I'm going to have round brackets. And I'm also going to have a trailing comma as if it suggests there's something else. So let's do that, and then let's change what the names are there. Let's run this like this, and it'll tell us what type this is. So it knows it's a tuple because it has the round brackets, and it also has that leading comma there as well. So let's just remove the type and see what it thinks this is. Run that, and you can see that it's just returned the tuple as we would expect. Okay, next we're going to do bytes. So let's create Kev's bytes. Okay, let's run that. So get the value 1 there. And what I'm going to do, I'm actually going to wrap this in. I'm going to show you first of all, if I go and print out what kind of type this is, it's actually going to think that this is an integer. It will default to integer because it's kind of its catch-all thing for using with numbers. But if we wrap this in a bytes, like so, and now we run it, it's now of class bytes, and bytes are much smaller than integers. Integers can be, I think, at least 2 bytes because it can store longer and longer numbers, and in fact Python hides all that kind of detail from you. It can basically just add more and more bytes to an integer, as many as it needs to store the large number, whereas a byte is always going to be 255. That's the maximum it can store. Let's take the bytes away a second and show you what that binary value looks like when we run that. The value 3, if we did that there, that would be the value of 7, and the next value would have been 8, that would be 15, then it'll be 31, and if we do the next one, it'll be 63, and then it'll be 127, and then finally 255. Okay, so that's all the different things that we've looked at there. We've looked at tuples, we've looked at list dictionaries, text strings, and numbers as well. There's a small number of words that have a special meaning in MicroPython and therefore can't be used for any other purpose. And it's actually a smaller number than you might think. So when you're learning a new language, a new computer language, you don't know what all the special reserved words are before you start out. And it can seem quite intimidating because you think, how can I write a program if I don't know all the possible words that exist in there? So it's a smaller number than you would imagine. This is the list of reserved words. There's also things called operators, which we'll look at later on, but the actual number of these things is actually quite small. So don't worry about it, don't feel overwhelmed. You know more than you think you do, and there's less to learn than you think there is. So let's have a look at how data is stored in MicroPython. So we looked at a byte before, this 255. This is how bytes work in binary. So in computing, a byte is 8 bits, 8 ones and zeros. It's always grouped together in that kind of size. In the older days, we had different sizes of bytes. They might have like 12 bits in them or 16, something like that. They might call that a word. And also there's a group of 4 bits is called a nibble. Well, that doesn't really get used very much. So a byte is 8 bits, and a byte can store 256 different values. and bytes are used to store data and represent things in computing. So there we've got our little cells down there, and there's 8 zeros represented. And the way that we count in binary is each one of these cells is an order of magnitude larger than the previous one. So we start out with the first one is the value 1. The next one next to that is value 2. This is how numbers are represented. It can seem a little bit unusual at first, but you can do some really interesting math. We regularly think as humans in base 10. We work with a base 10 number system, and computers work with base 2, which is just ones and zeros. So you can see there that the very first value, all the numbers are 0, the 0 value. If the first digit is a 1, then the value is 1. The second digit is illuminated if that's that. So it looks like it's 10, but it's actually 1, 0. That's the value 2. And then if you have 1 and 1, that the value is 3, because you're adding together those two top things there. So if you wanted to have 4, you would have 1, 0, 0. If you wanted to have 5, you'd have 1, 0, 1, and so on. So you can see there, this is how we represent numbers in computing. And really, this is all that's happening at a really low level, is the circuitry is essentially adding these numbers together through AND or NOT or NAND gates. And we'll have a look at logic and things like that a bit later on in the series. So what about representations of these numbers and how do they scale up? So you've seen what 1 byte is. That's 8 bits, and that's usually represented with the capital B character there, and it can store things like the letter A or the number 1. It can store very small values. The next order of magnitude up then is a kilobyte, so that's 1024 bytes. And the reason it's not 1000 bytes is because we're using binary. That's usually represented with a lowercase k and the capital B, and you could store in 1 kilobyte the entire text of the poem Jabberwocky by Lewis Carroll, or you could store the favicon, the thing on your browser that shows you like a little image of which website you're looking at. You could store that in 1 kilobyte. If you have 1 megabyte, which is the next one up, you could store the entire text of Harry Potter and the Goblet of Fire on there. So a megabyte can store quite a lot of text in there. So the next order up is a gigabyte. So a gigabyte is 1024 megabytes. We use GB for that, and that can store about half an hour of video. The next one up from that again is terabyte. So if you're buying a laptop in the 2020s, they'll often have a 1 or a 2 terabyte hard drive or SSD, and that can store quite a lot of stuff. So you can store on there the entire series, all 61 episodes, for example, of the Avatar: The Last Airbender in 1080p. And the next order of magnitude up from a terabyte is a petabyte, and that's 1024 terabytes. And that's about 2,000 years of MP3 encoded music. Next order of magnitude up is the exabyte, so that's 1024 petabytes, and that's about the global internet traffic worldwide in 2004. 1 zettabyte is the next one up, and that's 1000 exabytes, and that's the global internet traffic of 2016, so that's quite a lot of data moving around. Next we have yottabytes. Yottabytes is 1024 zettabytes. And currently there is nothing that works at yottabyte scale. It's just such an astronomically large number that we've never actually had anything reach that size yet. Then we've got ronabytes and quettabytes, and they are again ridiculously sized. I wonder if we'll ever see anything in our lifetimes that come anything close to that. Okay, so let's have a look at controlling the flow of our program. So previous to this, we've written small programs that just do essentially a list of simple tasks in order. Now, what happens if we want to make a decision in our program? What happens if we want to sort of branch off depending on the value of one of our variables in there? We need to use the if statement. So you can check the value of your variables using the if statement, and depending on what the value is that you're checking, what the condition is, then you can do something. So using if statements, we simply need to have a condition to check and then an action to perform if that condition is true. So let's go and have a look at that. Right, so let's have an if statement. So I say if the name equals Kevin, then we can use the little colon, and then we can say print hi Kevin, like so. Just comment that out at the bottom there because we don't need that to run anymore. So I'm literally just pressing Command and 3, which puts this little hash in the middle there. You can sort of turn it on and off just by pressing Command and 3 on a Mac. I think that's the Alt key on Windows, and or you can just manually type the hash there, but it basically tells MicroPython, ignore this, it's just text. Right, so let's run this again. And it says hi Kevin because the name variable is Kevin, so that works well. If we change that up here to be, let's do it lowercase Kevin, and then run that, it doesn't do anything because that is not the same. A lowercase k is not the same as an uppercase k. So nothing happens because the if condition just says if the name is that, then print, otherwise carry on. So we could have this little program here. Instead of saying Kev's Bytes, we could just say end of program. So run that again. You can see there, hi Kevin, end of program. If we change that back to like a lowercase one or Levin or something like that, it just says end of program. It's just gone past the end there. Now, the other things I want you to look at there is that where we've got the if statement, so we've got the condition there, name equals Kevin, and then we've got this colon, and then we've got a new line, and it's indented by 4 characters. You can see there, 1, 2, 3, 4, and then we've got print. And this is something that Python does to understand a block of code, because we might have a couple of statements here. We might have another statement that says print. We can see there that it's actually executing this block of code. Now, if I didn't have that there, if I just indent that, I'm doing Shift and Tab to make it sort of unindent, and I run that, it'll complain. It'll say it's invalid syntax. You're not following the convention, which is if you have an if statement, you need to indent your block by 4 characters. So that's how we do a very simple if statement. So let's get back to our slides and let's have a see what else we can do beyond an if statement. There's also the else statement, and these come in as a pair. So far we've checked to see if a condition is true, then run that block of code, print the message out in our case. But what if we want to run another piece of code if the condition is false? So what we could do is we could say if a equals 1, for example there, that's the condition, print a is 1. And then we could have another condition that tests if a is not 1, which is what that exclamation equals means. If it's not 1, then print a is not 1. And we could just have a whole series of these if statements checking various different conditions. It's not very efficient. We want it to check if it is a particular condition, do one thing, and if it is not, then do something else. So that's why we have this else statement, and it just makes our code flow better. And actually it's quicker because if it's true, it has one branch. If it's false, it has another branch. We're not having to test each individual condition. We test the condition once and then have 2 different actions depending on the outcome. So it's quicker if we use the else statement. So else means run the block below if the first condition was false. If that condition is not true, then run the else action instead. So let's give that one a demo. Let's get back over to Thonny and let's do an else statement. So if your name isn't Kevin, else, it's not indented, it's at the same indent level as the if statement. We have the colon and a new line, and then let's say, who are you? Okay, so if I now run this, it'll say, hi Kevin, how you doing? Because it's running that first check. The condition is true, name is Kevin. We go over here and we change this to Levin instead. It's going to say, who are you? So instead of saying, hi Kevin, how you doing? It's running this other, because the condition was false. It's running this other statement instead, which is who are you? And then it's ending the program after that. Now there's another thing that we can put in there. So what happens if there's more than one condition that we want to test for and we don't want it to keep checking every single thing? We can use an Elif. So if statements have this one more trick, it can run another alternative block of code after checking and running the first block or before it's run the else statement. So Elif is short for else if, and it sits between the first if statement test and the final else statement. So we can have quite a few of these other tests to do in there, and then we can finally, if none of them are true, we can then run the else statement instead. So only one of the blocks of code will actually run. We'll check that in our test in a second. So let's go and have a look at that on Thonny. So what we're going to say else, we're going to say Elif, and we're going to do another condition check there. So if Elif name equals Alex, then we can say print hey Alex, and we could have another Elif, let's say name equals Jenny, and we can then say print howdy Jenny. Okay, so let's try this out now. So there's our program. Let's run that. So first of all, it isn't Kevin, Alex or Jenny. It's currently Levin. So let's change that back to Kevin and see what happens. So it's saying, hi Kevin, how are you? So the program is coming along saying if name is Kevin, then print hi Kevin, how are you doing? And because that condition is true, it then skips past the Elif, and else because that condition was true. So let's try making that to be Alex instead. Let's run that. And it says, is name equals Kevin, which it doesn't, so that's false. Else if name equals Alex, it does. So it's saying, hey Alex, and then it's skipping to the end because that condition was true. And it will only run one of these blocks of code if it finds one of them to be true. So then we can do a final one to be Jenny. Let's run that again. So it says, howdy Jenny. So it said, if name equals Kevin, it doesn't. Else if it equals Alex, it doesn't. Else if it equals Jenny, it does. So howdy Jenny, and then it ends. Otherwise, if it doesn't recognize this, so if we have, I don't know, Archie in here, it doesn't recognize Archie, and it just says, name is Kevin, it's not. Else if name is Alex, it's not. Else if name is Jenny, it's not. Else print who are you, and then end the program. So that's the if else with the else if in the middle. So there's an easier way to write some of our code. So when we're checking a condition, we could say, and these are for true or false statements. So if we say A is true, notice it has a capital T as well on there. So if A is true, we can say print A is true. But there's an easier way to write this, because it assumes that things are going to be true. So we can actually get rid of that check that says equals true. We can simply say A is true. If A is true, because it's looking to see, is that true? Print the A is true thing. So we don't actually have to put equals true. It will assume that the test is to see if this variable is true. So that's a nice way of making our program just a little bit tidier. We don't have to put that extra bit of code in there. It's assumed to be true. So if you enjoy what I do and you want to see more of this, please give this video a like. Drop me a comment to know how you're finding this course, if it's the right pace, the right pitch for you. And also hit the subscribe bell just so you get notified when I go live again. And I do go live every single Sunday at 7 o'clock GMT. We're out of British summertime, daylight savings time now, so we are true GMT once again. Okay, if you've not already joined our Discord server, head over to kevsrobots.com/discord and you can join our free Discord server and have a conversation at a deeper level with me and all the people that have joined there. We've got a couple of hundred people on there now. And finally, if you want to follow me on social media, you can do that by going over to Instagram. I'm at Kevin McAleer at Instagram there. And on Twitter, I'm at KevsMac. So you can follow me there. And also you can just see underneath me there, I'm also on TikTok. I've been giving that a go and having quite a bit of success actually. I'm Kevin McAleer 6 on TikTok. And then if you want to help support the show, you can do that by doing a super thanks. And you can also go to kevsrobots.com/coffee if you want to buy me a coffee and help support the show. It takes me quite a lot of effort and energy to put these shows together, so I really appreciate it if you can help out the show financially too. And finally, you can actually join the YouTube membership program. There's a little join button. You can click that once you're a subscriber. You can join the membership program too. And if you want to get your name up in lights on the screen just over here, you can do that by going over to kevsrobots.com/credits. If you bought a coffee, you join the membership program or the YouTube membership program, you'll also get your name over here too. So you can see there we've got quite a few members, supporters and YouTube members showing up there too. So I hope you enjoyed this lesson and I shall see you in the next one. Bye for now.